Well, welcome to the Facebook Live tonight. Welcome to Math Strat Chat. So, Math Strat Chat normally is where we ask a math question to the world and then we talk about our strategies. We chat about our strategies, Math Strat Chat. Tonight, we're going to do something a little bit different. I've actually been wanting to do this for quite a while, and this whole crazy coronavirus thing has got me sort of propelled me into doing some things that I have wanted to do and just haven't quite done yet. So normally in Math Strat Chat, I throw out a math question and then the world answers, and often I'll comment on it, and I encourage people to comment on each other's. But I wonder if you've ever wondered, how do people come up with those strategies? Now, I've even started to ask people, like, where did you learn to do that? And how did you know that to use that relationship? And often I get some really interesting responses. But what I don't hear very often at all is that people were specifically taught those relationships, that it was an explicit thing that the teachers had in mind that students would learn. Somehow people have just picked up these relationships. I want to leave a lot less to chance. I was late in my life when I learned that there were relationships that we could use to solve problems, when I could actually mathematize, do what mathematicians do to solve problems. And I want to share that with the world. I think all of us can do more real math than fake math. We just need to know it's a thing. How do we do that? I think the best way to do that isn't necessarily Math Strat Chat. I think Math Strat Chat's a fine way to sort of get some conversation going, but it's not really a great way to develop relationships, to develop mathematicians. So what is that way? Well, let's do that tonight. Tonight, we're going to do my favorite instructional routine called problem strings. I give a lot of credit to the Freudenthal Institute and Kathy Fosno and Martin Dolk, where I learned problem strings from. Cara M was a big inspiration. It's an instructional routine where we do a string or series of problems and in a certain order that is intended to help the learner create relationships and connections in their heads. I'm going to just make sure, okay, we are good. We are golden. All right, so I'm going to do a string or series of problems in a certain order, and I'm going to encourage you to solve them right along with me. There'll be a few times where I'll pause and we'll read to see what's happening in those things, those posts that you have below. I'm trying to say messages. I know that's not right. Whatever you call it. Comments. There we go. Woo! Is it Wednesday already? Yeah. All right. So go ahead, and I encourage you to grab a paper and pencil if you want to jot some things down. For many of these problems, I think you'll be able to do them without writing anything down, but it's totally legal to keep track of your mental thinking. All right, you ready? This is a string or series of problems, a problem string. At the end, we'll talk about what relationships I was aiming to develop tonight, that this problem string could help students develop. All right, here we go. The first problem tonight is, what is 19 times 0.5? So the first problem is 19 times 1 half. 19 times 1 half, 19 times 0.5. So go ahead and solve that any way you want. Let everybody think for just a minute. Thanks for everybody for joining in. Got quite a few people coming in. Excellent. So everybody's thinking about 19 times 0.5. I'm going to just pause for a second. You're welcome to type your answer in if you want. I might move on before you're ready, but thinking. Okay, cool. So I would then ask students, like, how are you finding 19 times 0.5? How are you finding half of 19? Oh, I might say that. Yeah. And then I'll let students think, and then I will ask them how they're thinking about 19 times 0.5, and I'll probably do some modeling of those relationships. So I'm going to go ahead and say we are thinking about 19s, and I want to know about 0.5 19s. This is a way that I could start to model things. Well, I think that we could have kids say that they're thinking about a half of 19 as thinking about a half of 18, and then a half more of that one that's left over. And so they could say a half of 18, that's just 9, and a half of 1, that's just 0.5. And so they could find that as 9.5. That could be one way that they could think about a half of 19. So up here, I might say that that is 9.5. What would be another way I might expect kids to think about a half of 19? So I actually worked with a 6th grader today, and that 6th grader, Luke, you did a great job, said that he thought about 19 times 0.5 as half of 10, and then half of the leftover 9. Those make sense, right? Those relationships make sense to use to find half of 19. Absolutely. Give me just a second. My camera's being a little bit funny. Come on. Oh, I know what's going on. There we go. Sorry. Half of 10 is 5, and half of 9 is 4.5, and we could add those together, and we could also get 9.5. And I might take even one more strategy. I might ask kids, how else are you thinking about half of 19? And I would wonder if there might be some kids who are thinking about half of 20, and then subtracting half of 1. So half of 20 is 10, and then they could subtract that half of 1, which is 0.5, and they could also get that 9.5. So I might ask kids to sort of share different ways they're thinking about that. I might model their thinking. I just did it with equations. I could have chosen to do some other things, but today we're going to use those equations. Cool. The second problem of our string. So this first problem up here, we decided was 9.5. The second problem in our string is, what is 19 times 10? So that's the second problem, 19 times 10. I'll go ahead and put the 10 over here. And then I'm not going to wait very long on that problem, because I think students can do that pretty readily. We know this thing times 10. Now, if students don't know times 10 or don't know half of the numbers that we just used, then this is not an appropriate problem string for them. But I think if you're on the Facebook Live tonight, it's probably appropriate. So 19 times 10, I'm not going to wait very long. Kids are just going to say that's 190, and I'll model that as, so if I scale 1 times 10, then I'm also going to scale the 19 times 10, and anything times 10, there has this place value shift thing. We could talk more about why that works, but not really tonight. Okay, so we got 10 19s is 190. The next problem in our string is, what is 19 times 5? And then I'll let everybody work. So go ahead and think about it, everybody. How would you solve 19 times 5? Go ahead and do it any way you want. Nice. Hey, my cousin's on. Hey, Allie. Good job. Good job. I like your strategy. Nicely done. Cool. Oh, I like some of those strategies. You guys are doing great. All right, so how are you thinking about 19 times 5? Well, I think that I might have some people say, so I'm looking for 5 19s. I think I might have some people say, hey, 5 is half of 10. And I can just go, if 5 is half of 10, then I can go half of 190. And then they can think about half of 190. I might model how that goes. Maybe I'm not going to do that right now to save time. But could I think about half of 190 as, is that 95? Is that right? Maybe we ought to model something like, if I'm thinking about 190 divided by 2, is that like 180 divided by 2 plus that extra 10 divided by 2? Is that 95? That'd be one way to think about that. We could do a couple of other ways, but maybe we'll sort of stop with that one. We could have done 100 divided by 2 and 90 divided by 2 would be another fine strategy. So I think some people will use the 10 that we just had to help them sort of think about 19 times 5. So we could sort of think that that might be 95. What's another relationship? I wonder if there's anything else up here you could use to think about 19 times 5. Like that 95. Does that look familiar? Like, have we seen something like that before? I wonder if I could think about that half of 19. Is there some relationship between 0.5 and 5? Oh, sure enough, there's this cool times 10 relationship. So if I scale that factor times 10, then I'm also going to scale this one times 10. And sure enough, is 9.5 times 10, 95. Oh, that's an interesting relationship. Okay, that kind of seems kind of cool. We could sort of do that. So two nice relationships that could help us think about 19 times 5. Now, there's some other ones, but those were two that I wanted to sort of highlight tonight. Cool. Next problem in our string. What if I ask you then later, what is 19 times 15? Wonder if there's anything up there that could help you think about 19 times 15. Go ahead and solve that on your own. Sue's doing advanced strategies. Nicely done. So letting everybody think. What might be some ways that we could think and reason about 19 times 15? Is there anything, do we have anything up here that could help us think about 19 times 15? Sure enough, so one strategy, and I would be calling on students right now. I would be looking at what they were doing, or I might ask, did anybody use the 10 to help them get 15? And then I might call on that student, and then the student would say, well, yeah, I could use the 10 19s and the 5 19s. And if I add that 10 plus that 5, that would give me 15 19s. And so can I add the corresponding 190 and 95? And what is that? Is that 285? Is that right? If I add that 190 plus that 95, the corresponding guys over here. Is that 285? Okay, so that could be one strategy that I could use if I've already got the 10 15s, or excuse me, 19s, and I've got the 5 19s. Could I add those together to get 15 19s? Absolutely. What's another strategy that I might use to find 15 19s? Is there anything else up here that I might be interested to use? Well, if I was a middle school teacher, I might want to nudge this strategy. I might want to look for students who are thinking about 1.5 19s, because we've got 119 and we've got 0.5 19s. So can I think about 1.5 19s, 1.5 19s? Could I add those guys together? Is that 28.5 if I add those together? And then from there, could we sort of scale that up times 10 and scale from there? And look at that nice relationship. That's kind of cool. So that could be another strategy that kids might use to find 15 18s. We're going to erase that one. All right, so we're 19s. I keep saying 18. So we've got 15 19s as 285. Cool. Anybody want to guess the next problem in our string? Well, the next problem in our string is, what is 19 times 100? Again, not a problem I'm going to wait on very long. If I'm doing this problem string with students, I would expect that these students could think about 19 times 100. Often kids at this point will say, ooh, that's just 1900s. And then we even call that number 1900s. Cool. So one way they could do that is just sort of know this thing about times 100. Could they also use this relationship? And instead of scaling from here times 100, could they also scale from the 10 19s times 10? And we end up with just one more zero. Okay, cool. One place value shift. Excellent. I'm not going to wait long on that problem. The next problem in our string, what about 19 times 50? Now I'm looking for 50 19. So I'll go ahead and throw that in here. Solve that any way you want. Just tell me what you got. Stephanie, nice one. Not one that I'm going to go over tonight, but nice. All right, we've got some excellent strategies going on in the comments. Nicely done. Okay, what are some strategies that we might expect students to use to do 19 times 50? Now, at this point as a teacher, I have some choices to make. I'm going to go ahead and make some choices right now to think about the one that we just did. I wonder if we might have students that say to themselves, well, 50 is just half of 100. So if 50 is half of 100, then what is half of 1900? And then we could have students do things like, well, if I'm thinking about 1900 and I'm dividing it by 2, could I think about that as 1,000 divided by 2 plus that extra 900 divided by 2? Is that just 500 plus 450? And is that 950? I'll go ahead and do that in purple. So we're thinking that half of 1900 might be 950. Okay, so that might be a strategy. I don't think that green is showing up very well. I might not use that the rest of tonight. Sorry about that. But we could think about the 50 19s as half of the 100 19s. All right, that could be a perfectly fine strategy. What other relationship might we use that we already sort of have up here? Is there something else? I wonder if we could think about this 5, the 519 that we have. Could we go from 5 to 50, scaling by times 10, and then also scale that times 10? Ooh, that's kind of nice. So if we already have 5 of something, do we instantly have 50 of them? That's kind of a nice relationship. So we can definitely go from 100, take half of 100. But we can also, if we already have the 5, we can go from the 5. Is there anything else up here that we could use to help us think about 50 19s? There might be one more kind of exciting one. Anybody go all the way back? This is a nice middle school solution. To find 50 of anything, could I find half of it? And then once I have half of it, can I just scale it up times 100 and scale that times 100? Whoa! So sometimes that's a really nice strategy. If I want to find 50 times something, I can just half it and then scale it times 10 and times 10 again to scale it times 100. That can be really handy when finding half the number is easy, but maybe finding 100 of it and then 50 of it makes the numbers kind of big. Using just half of it first, then I'm kind of dealing with smaller numbers, and sometimes that could be a nice solution. All right, so we have several different ways of thinking about finding 19 times 50 or 50 19s. Cool. The next problem in our string is, what is 19 times 150? All right, I'll let students solve that any way they want. We're looking for 150 19s. Everybody thinking. Thanks for putting your strategies in there. Hey, Ray, thanks for joining us tonight. And feel free to be typing your strategies in. I'm trying to keep up with them as we go. All right, so we got 150. Now, typically, the first strategy that I would ask for students is I might say, did anybody use the 50 that we just had? And then if student says yes, then I'm like, oh, cool. How would you use the 50? Did you add the 100 and the 50 to get 150? So then could we add the corresponding 1900 to the 950? Let's see, what would that be? 1900, 950. Let's see, 1900 plus one of those hundreds would be 2000. And then I would have 850 left over. So is that 2000 and 850? I kind of did that in the air. I could model that. Maybe I'm not going to for time tonight. Oh, maybe I will. Could I have said that I started at 1900 and I added the 100 to get to 2000 and I had 950. So now I have 850 left. And what is 2000 and 850? Is that 2000? Those would be ways that we would represent student thinking. So, one of the reasons I stopped myself and actually did it is because I really advocate that the way that we can help students learn these strategies that some of us just picked up naturally on our own, but the way that we can help all students pick them up is to make that thinking visible, to put those relationships out in front visibly so students have a better chance of taking them up. That's one of the ways that we can help students develop these relationships. Okay, cool. So that's one way that we could think about 150 19s. What other relationships do we have up here that we could use to help us think about 150 19s? Dun, dun, dun. Anybody thinking about, let's go for the red again. Thinking about coming from that 15? Could we scale that times 10? If I know 15 already. Now, if you don't know 15 already, it's not a great strategy. But if you know 15 already, can you just scale that times 10? Bam! And does anybody remember we had the 1.5 earlier? Remember when we had 1.5 in here and we decided that was 28.5? Once I knew 1.5 of something, could I also scale that to get 150 of them? And I'd have to sort of keep track of how many times I'm scaling that times 10. But could we use that relationship? Absolutely. So we have some really nice sort of relationships going on here. I wonder if anybody who has been active in Math Strat Chat lately is starting to recognize the strategy that people have been using to solve problems and how I'm trying to build those relationships. So that might become a natural strategy for other people to use. I think if all we ever do, Ray, like that, if all we ever do is show kids a strategy for a problem or a bunch of strategies for one problem, and we don't do this series of problems where kids can sort of look for relationships, this idea of doing a string of problems or a series of problems, this is the way that I built my numeracy. I was able to sort of make connections and relationships in my head and understand major strategies because we were looking at a string or a series of problems and having conversation about the relationships in between the problems. All right, what's the next problem in our string? Are you ready for this one? Dun, dun, dun. How about 19 times 149? Dun, dun, dun. Now, if you've been doing any kind of numeracy before, at this point, you're like, no problem. That's just almost what we just had, right? If we're looking for 149 19s, we just need one less 19. We had 150 19s. Now we only need 149 19s. We just need one less 19. Now, the subtraction is where it might bog some people down. It was really fun watching Luke today and his description of how he subtracted 19. Let's take a look at how we might think about if we're going to take 150 and we're going to subtract 1. Then over here, we're going to have to take that 1 corresponds to 19, so we're going to have to subtract 19. Could we think about 2,850 subtract 19 in at least one or two ways? Could we think about subtracting 19 as subtracting 10? Well, what is 2,850 subtract 10? Is that 2,840? Okay, and then we've got to subtract 9 more. What's 2,840 minus 9? Is that 2,831? So we think this might be 2,831 because we've taken this 2,850 and subtracted off the 19. Now, another way that we could do that, and I'm almost out of room here. Can you still see that? Yeah, we can. We could think about 2,850 subtract a little bit too much. We could subtract 20. That might be a bigger jump there. 2,850 subtract 20, is that just 2,830? Is that right? Ooh, I'm a little low. Sorry about that, everybody. And if I'm at 2,830, but I was only supposed to subtract 19, I've got to adjust up 1. And then I'm in this great place. What is 2,830 and 1? And there's our 2,831 answer. So don't get bogged down in the subtraction. Still think and reason. Sometimes in the beginning of my classes at the university, my students will learn about subtraction, and then we'll start doing multiplication and division problems like we're doing tonight. And then they'll revert, they'll go back to algorithms. Keep thinking. Get your brain engaged in the relationships, and it can kind of be fun to see which relationships you can play with. All right, we're almost done with this problem string. Let me be really clear. This string is a little bit longer than I might do, especially if it's the first string I do with students. But as long as you keep things lively and you keep looking for relationships, it's kind of fun to do stuff like this. Steve, great question. It's absolutely using the idea of 5 is half of 10 to get me to the 150, and then a little bit of over under to back down to the 149. I could use similar reasoning to get 151 19s. But the next problem on our string is not 151 19s. It's actually 19 times 145. So I'd like to have 145 19s. So what relationships could you use to think about 145 19s? I wonder if there's anything up here that could help you think about 145 19s. What everybody think? Ray, like that. Nice. Cool. 145. What do we have up here that we could use to think about 145 19s? So I'm going to ask Kim later. I bet Kim's listening. She says I always talk while I'm trying to get people to think. I think I just did that. Sorry. So what relationship are up here that we could use to get 145 19s? A lot of students at this point will think, well, I've got 150. Sometimes they might try to think about going from the 149, but I wonder if we could go from the 150 and use that 5 that we have up here. Could we think about 150 minus 5 to be 145? Then what would we need to do over here? This corresponding 2,850 subtract 95. Ooh, what is 2,850 subtract 95? Could we think and reason about those relationships? Let's see. If I've got 2,850, could I subtract 100? Let's do a little over subtraction. 2,850, is that 2,750? But I was only supposed to subtract 95, so it's a smaller jump, that 95, by 5. So what is 2,750 and 5? Bam! Is that just 2,755? Okay, as long as I'm like live here on Facebook, so I think I'm doing this all correctly. Somebody in the chat's going to tell me if I've got something wrong over there. Ooh, nice. Yep, Bethany, I totally agree that you could find 150 of them and subtract 5 of them. Nicely done. Great strategy. Take the 95. Yep, excellent, Shannon. Is it Shannon? I think it's Shannon. Whoa, I can't see. Kim. Ha! Yeah, see, Kim's right. Kim's always right, by the way. Okay, so that would be a great strategy for us to find 19 or times 145 or 145 19s. Teachers, you might notice that as we go, I am erasing the representations that I'm doing. I actually worked really hard to see how I could model this today because this shiny stuff sometimes makes my camera go crazy. So we actually messed around with the settings and everything. So I think we're doing pretty well that the camera's not going too crazy. I know there's this glare. We did everything we could do to get that glare as light as possible. But you'll notice that I think it's really important that we sort of clean things up and keep things so we can use the relationships that we have to solve other problems. The last problem on our string. Anybody want to guess? What would be a really good one to end on? I could think of several, but here's the one that I'm going to choose tonight. What is 19 times 145.5? You can do it. I think you can. All right, y'all, take stock of your brain right now. Did your brain right now go, okay, all right, what do I know? Hey, I know 145 19s. Hey, I know a half of 19. Bam! I just need to add those together. Could we literally just add the half of 19 and the 145? I don't know. Is that going to be really hard? What is 2,755 and 9.5? Let's see if I add that. 2,755 and 5. Does that land on 2,760? What do I still have left? 4.5. What is 2,760 and 4.5? Is that just 2,760? Whoa, now I'm running out of room to write. 64 and a half. 2,764 and did we just find, this is 145.5 right there. Did we just find the answer to a 4-digit by 2-digit decimal multiplication problem? Thinking and reasoning, using relationships that you own, using other problems that you own. Y'all, this is an example of a problem string, a string or series of problems written purposefully in a certain order in order to construct relationships and connections in the learner's head so that you can now use a strategy that we call 5 is half of 10. It's honestly not my favorite name. In fact, I offer right now, I will give you your book of choice. If you can give me a name, I have to like it, by the way. So I've offered this to several people. We haven't come up with one that I like, but a name that describes this idea that to find 50 times anything, I can find 10 to go to 5 and scale it up. I can find 100 and cut it in half. I can find 0.5. I can find a half and scale that up 100. To find 150 times anything, I can find 100 of it and half of that of 50 of it, add them together. But I could also find 1.5 of them and scale that up to 150. This idea that 5 is half of 10 can play out in lots of really cool ways. If you've never seen it play out, check it out. It happened in a huge way in last week's Math Strat Chat. Last week's Math Strat Chat was a crazy problem. 1617 divided by 33. And I could have written that in a couple different ways, right? I could have written it like that. And I think on the post, I actually wrote it like this. And if you own the relationship that 5 is half of 10 and 50 is half of 100, there's a brilliant strategy that you can use that actually works out really nicely to solve that problem. I don't know that I'm going to mess with that. I'm going to sort of let you could look back on the strategies from last week, or you can mess with it now. But how might you use the idea that 50 is half of 100 if you're thinking about how many 33s, if you're trying to scale up 33, I'll give you a little start on that problem. If I was thinking about 33s and I want to work that 33 up to 1617, I wonder if there's something, oh, maybe I'll give you a little bit more of a go. What if you had like 100 33s? How much is that? Like, it's way too much, right? Is that 3,300? 5 is half of 10, 50 is half of 100. I wonder if you're like encouraged to do anything with those relationships at this point. Y'all, my point is that several people used that strategy to solve this problem last week, but I don't think I've done a good job on Math Strat Chat of being really clear about how we can develop those strategies, how we can help everybody create those relationships and connections. So I launched to the world tonight that Math Strat Chat is not just all about sharing strategies, but as teachers, we can help students build those strategies, develop as mathematicians, develop relationships and connections in their heads so that they can solve problems like the rest of us are now. I come from a background of having had no numeracy as a high school math teacher. And so I dove into the research in a huge way because my kids were mathematizing and I was enamored by the way they were thinking and reasoning. And I learned that there are these things that mathy people do in their heads that I just never knew about. As an adult, I was like, wait a minute. I never knew, I knew 5 was half of 10, but I didn't ever think about how I could use it. If I would have seen a problem like this, written any of these ways, then I just would have literally started seeing steps to do, not what do I know? What relationships and connections do I know that I could use to solve the problem? Let me just tell you, that's what mathematicians do. Mathematicians use relationships and connections to solve problems. They don't perform a series of memorized steps. Mathematicians don't mimic. I think we can all mathematize. All right, you guys have been fabulous. There's a little bit of fun that we had tonight. I hope you enjoyed our problem string. If you'd be interested in a write-up of this problem string, I think we've pinned it. Yep, right at the beginning of the Facebook Live tonight. You can download the free guide for this string. It has questions to ask. It has the order of the problems. It has all this modeling that I did in step-by-step where you can see all the different scaling and different strategies that we use. So if you're interested in that, you can totally download that for free. No problem. Scaling similar numbers. Nice. Oh, Steve's got a name for me. Let me try it. How's this? 2 and 5 are intense. Complimentary friends. I'll be thinking about that one, Steve. That's a nice try. I should know Steve was going to come out with a good one. So you can totally download that free guide for this particular problem string if you're interested in that. Let me tell you one other thing. Y'all, we are in this crazy, unprecedented, unpredictable time. I am trying right now to figure out what my summer is going to look like. I do a lot of professional development in the summer, and all of that's a little bit looking like we don't know how that's going to go. So we're doing a lot of pivoting, trying to figure out what it means. I know everybody, teachers are trying to figure out what remote learning looks like. Parents, you're trying to figure out what remote learning looks like. So we're all in this really strange place. Something you might be interested in. If you're not, totally just ignore it. But I have an online workshop that I think is pretty cool that does exactly what we did tonight with proportional reasoning. If you're interested to see more of what I do in a workshop format, it's an online workshop, and we have a special 20% off running right now for the crazy that's happening in our world. We're running it at a different time than we normally do to try to offer to people in case that's interesting. I totally know a lot of you teachers are scrambling right now to get things done. If that's not in your worldview, don't worry, we'll run it again later. But if you're interested right now, 20% off, you can use the coupon code GW2020. Somebody will put that in the notes in the comment slide. You're more than welcome. That would be a thing that you could do. We'll run it again this summer, so you could totally take it again then. If you're a teacher and you're interested to do that and you would be paying out of pocket, email me at pam@mathisfigureoutable.com for a special discount for those teachers that are paying out of pocket, if that interests you. One other thing I wanted to mention is we have some Facebook groups. If you're interested to join our teacher Facebook group, you're welcome to do that. That way you'll be notified when we do more Facebook Lives, when we do any new stuff. We try to make sure that it lands like this page. Join the teacher Facebook group. Parents, if you're on, you can join the parent Facebook group. We're going to try to be putting out more free guides. We have some game guides and some other fun things that you can find in those parent and teacher Facebook groups. All right, I was aiming for a half an hour. Bam! We got a half an hour. All right, I'm getting better at planning these Facebook Lives. I hope you guys enjoyed this. I'd be interested in your feedback. If you're on tonight and you want to give me a feel for how you like this version of Math Strat Chat, so the normal, typical version of Math Strat Chat's not coming out tonight, I think what we might do is post one of the problems like, 19 times 145.5, and then see what other people do who weren't necessarily on here tonight. Maybe we'll do that, or we might just post this Facebook Live instead of Math Strat Chat, maybe every once in a while. So let us know. I'd really be interested in your feedback on if you enjoyed tonight, or if you'd rather have us go back to the old Math Strat Chat all the time. I think we'll definitely do a mix of both. I don't think we'll do one, only one or the other. If only because I don't always have Wednesday nights free to be on video. Y'all have been fantastic. Stay safe, stay healthy. I heard the other day somebody say, don't social distance, physical distance. And I'm going with that, y'all. Don't distance socially from people. If anything, I think we should be connecting socially big time. Get on the video with your kids, with your friends, with your family, whatever you can do to stay connected in this crazy isolating time. Distance physically, absolutely. Let's get the virus slowed down. But I really encourage you to connect with fellow friends. Again, you're welcome to email me at pam@mathisfigureoutable.com, or through your questions and comments in this chat, and also in the Facebook group. So I'm going to sort of check stuff out. Thanks for putting the code in there. I appreciate that, Bethany. Thanks, Steve, for joining in. Annalise, great to have you. Beth, thanks. More strings. All right, that's good to know. I'm just looking to see. Lois, how you doing tonight? I'm a little curious to see if we got anybody from Twitter over. I know Steve is kind of multi or ambidextrous in both. Cool. Shannon, excellent. It's good to hear. Nice. Thanks for joining in, Bethany. Boy, it's hard to call you that. That's my cousin. She's Buffy to me. All right. Hey, it was fabulous. I think I'm off. Have a great rest of your Wednesday evening. Take care.